So, what's actually electronegativity? Imagine two kids are sharing a rope toy. If one pulls harder, the toy moves closer to him. So I have atom A and atom B. Both are making a covalent bond by sharing electrons, but they become greedy. This atom A tries to pull the electrons more to itself and becomes happy, and atom B becomes sad. But if atom B pulls the electron to itself more, it will become happy, and atom A becomes sad. So the electron shared between them, but both of them trying to attract it. The atom B is more electronegative actually, and it will pull the electrons closer to itself. So again, electronegativity is how you are able to attract the electrons to itself. If atom P is more electronegative, it's going to attract the electrons to itself more and wins. While if atom A pulls more, it's more electronegative and it will attract the electron to itself more. Looks how the atom P will become sad. So let's see hydrogen and fluorine. It's a battle for the electrons. The hydrogen tries to pull the electron pair, but it's not very effective. Actually, the electron pair cannot be attracted to the hydrogen. Its electronegativity is just 2.2, while fluorine electronegativity is much stronger. Its ability to attract the electron to itself is more. It pulls the electrons pair with its high electronegativity. It's 4 electronegativity. So if the hydrogen tries to pull, it's not very effective, while fluorine can pull the electrons more to itself and wins in this fight. It has higher electronegativity. We will know the reason for this later, but just to say now that its small size and high nuclear charge create a strong pull on the shared electron pair. While hydrogen electronegativity is only 2.2, so the electron pair is drawn closer to the fluorine in the hydrogen-fluorine bond. This is for sure an electronegative element which has the highest in all elements, and it can pull the shared electrons of the covalent bond to itself. So electronegativity is how strong an atom pulls shared electron toward itself in a bond. The more electronegative an atom is, the more it pulls the electrons closer to itself. But why some atoms pull electrons in covalent bonds more strongly? Why some atoms like fluorine are more electronegative than the hydrogen? Let's see the fascinating science of electronegativity. The factor number one, which makes why some atoms attract electrons more and it is more electronegative, is the nuclear charge. How many protons are there? Atoms with more protons in their nucleus have a stronger nuclear charge. They create more powerful attraction of electrons. It's very normal that fluorine, that has 9 protons, pulls electrons which are shared between it and the hydrogen more strongly than the hydrogen. The hydrogen has only 1 proton, making the fluorine more electronegative for sure than the proton of the hydrogen or the atom of the hydrogen. So the attraction force of the fluorine is strong, while the attraction force of hydrogen is weak. This is factor one that makes the fluorine attracts the electron more. The second factor is the atomic size. The distance between the electrons that this atom is trying to attract and its nucleus. The atom and the having some protons here that's trying to attract the electron. Let's see potassium versus fluorine. The distance between the nucleus of the fluorine and the atom that it is trying to attract is much shorter than the distance between the nucleus of the potassium and the electron that it is trying to attract. So the smaller atoms have shorter distance between the nucleus and the valence electrons. According to Coulomb's law, the attractive force is inversely proportional to the square of the distance. This is why fluorine, the small atom, pulls electrons more strongly than potassium, the large atom. So as a summary, the smaller the atom gets, the more power it can to attract the electrons than the bigger atom. So now I have known that the atoms are not similar in their electronegativity. Some of them attracts the electron more than the others. If they have more number of protons, they will attract the electron more, and if they have smaller size, they will attract the electrons more also. So now we have an electronegativity race, which elements gain pulling power as we move across the period. If we compared elements lithium with beryllium, boron, carbon, nitrogen, oxygen, and fluorine, and try to see which one wins, we'll see that the electronegativity of the fluorine here is the highest one. As we move from the left to the right across the period, the atoms will become smaller and they will have more protons for sure in their nucleus. If you compare in the periodic table and see how many protons are there in the lithium versus fluorine, you will see that the fluorine has more protons. This combination creates stronger electronegativity or stronger electron pulling power, reaching its maximum with fluorine. The most electronegative element in this periodic table, not only in this period. So let's start the race and see the electrons being attracted. Less here by lithium, the beryllium attracts it more, the boron more, the carbon even more, nitrogen attracts more, oxygen more, and the fluorine is the most. This is the king. This is the one that will win if compared to other atoms. So if lithium and beryllium are attracting the atoms, this one has more protons and smaller size. If you compare boron to nitrogen, this has more protons and smaller size. The fluorine is the winner because the fluorine has the highest number of protons and the smallest size. So in this period, and actually in the whole periodic table, it has the strongest electronegativity power. So apparently we can compare between the different atoms in such a trend. A trend is you can just look at the periodic table and try to compare different atoms according to their electronegativity. So just by looking at the periodic table, you will see that when you go to the right in the periodic table, if you take one period and move on the right, like element 1 in group period 2, and then you start going to the right, here the electronegativity starts to increase. So the greener the color, the electronegativity becomes more, and the red or orange, it is less. So I can see lithium here, the electronegativity is 0.98, 1.57, 2.04, 2.55, 3.04, 3.44, and 3.98. So I can say that electronegativity is the measure of atom ability to attract shared electrons in a chemical bond. The higher the electronegativity, the stronger the atom pulls the electrons toward itself compared to another element. Explore the periodic table to discover how electronegativity values change across the periodic table. The trend is that if you go to the right across the period, means from the left to the right, the electronegativity increases from the left to right. But the meaning of across the period means if you move along one period, you choose one period and move from the left to the right, it increases. Down the group, the trend is that the electronegativity decreases from top to bottom. So if you choose group number 17 and you go down, chlorine is 3.98. If you go down, this is chlorine 3.16. You go down, bromine 2.96, 2.66, 2.2. Again, if you choose group 1, 2.2, 0.98, 0.93, 0.82, 0.82, 0.97, 0.7. So down the group, the electronegativity starts to decrease. This means if you want to go for the highest, you go to the right, because when you move to the right, it increases and you go up. That's why fluorine has the highest electronegativity. If you want to decrease, you will not move right, you will move left, and you will not move up, you will move down. So you go down, 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 and left. Here you see the francium. 0.7, the least electronegativity in all the elements is the francium. Group 1 and period 7. You go right, it increases. You go left, it decreases. You go down, it decreases. You go up, it increases. So now you can know anything about the electronegativity from this periodic table. It will be available in our website k-chemistry.com in our electronegativity topic, and you can find the link to it in the YouTube. Fun facts about the electronegativity: the fluorine is the champion. It has the highest electronegative element of all elements. Electronegativity of all elements 3.98 make it the most electronegative hungry element on the periodic table. The electronegativity difference will allow us later in the next sessions to know what is the type of bond which will be formed. If you notice that the helium, neon, the argon, the krypton, they have a special color here. They have no electronegativity Why is that? They have complete electron shells. They don't care about this fight. They don't form any bonds. That's why electronegativity values are not typically assigned to them. The francium is the most generous one. It is the element that has the lowest electronegativity, making it very willing to give the electrons away rather than share them. Thank you so much for seeing this video. Again, you can use the Electronegativity Explorer in our website and many other tools, and you can also find notes which has the same information in our links in the description. Thank you and see you in the next video. Let's know together how this electronegativity is going to make difference and decide what is the type of bond between two atoms according to what happened in the fight about electrons between them.